Good evening, everyone. The lesson today is lesson 7.6 about find probabilities of compound events. Last time we studied what is the meaning of compound events. Is doing more than one event at the same time. Okay, and we learn how to find all possible outcomes, which is the sample space. This is what we studied as last lesson. Okay, today we want, after you find the sample space, we need to find probability of an event, specified event or something like this. So let's start the lesson. Sati has ticket left at the school fair and she hasn't yet won a prize. She decided between two games. Which game should she play? Okay, so she doing what? She has a spinner, okay, and a coin, and she will make compound event. She will flip the coin and then doing what? And spin the spinner, okay? And we will see the probability of having a prize, okay? Heads, it's to win a prize. Flip two head, if she gets, she told us, if she flip two head, she will win a prize, okay? So, use the table to determine the probability of winning a prize playing flip to win. To playing flip to win, we will throw it 2 times, okay, to get two head. Actually, the probability is HH, and we can know that we can make head and tail in the row, head and tail in the column. 2 multiply 2, 4 events. So all possible events are 4, so denominator will be 4. And head will appear 1 time, so it's 1/4, or we can write it as 25%. Okay? This is to get two head at the same time. Okay? Step 2. Use the table to determine the probability of winning prize playing flip and spin at the same time. Flip and spin at the same time. Flips a coin will give you head or tail, which is 2 events. And spinning the spinner will give you 4 results. Red, yellow, blue, green. So it's 4. So 2 multiply 4 supposed to be 8, so the denominator will be 8. Okay? What is the probability of getting blue color with head? She will win if she spin blue and head at the same time. How many times it's appear? Blue with head? 1 time only. So it's 1/8, which is equal 12.5%. Okay? So comparing the probability of winning each game, the probability of winning the prize flip the coin 2 times and get 2 head at the same time would be 25. So her chance to win is 25%. But the probability of winning a prize by flipping the coin and spin the spinner, okay, it will be 12.5. So Sadie is more likely to win a prize playing flip to win. So it's playing flip to win is more likely to win a prize, okay? So she should use her last ticket to play flip to win. So the next, it's better for her to choose her ticket to play the game of flip to win. Okay? It's better. Her chance is more than her chance with spinner and coin. Okay? This is how to calculate the probability of an event inside the sample space. One event on the sample space, so it's 1 over the all possible outcomes. In the case of head, flipping the coin 2 times, I have 4 arguments. So it's 1/4. In the case of spinner and coin, it will be 8 arguments. It will be 1/8. Okay? This is how to calculate the probability of an event inside compound event. A designer of flip, spin, create a new game using 5-section spinner, as shown. How does new spinner change the probability of winning a prize? Using 5-section spinner, the probability of winning a prize is, okay, we have to make what? We have to make the spinner, the table. Spinner have how many color? First, I have for the coin, head or tail. And for the spinner, it may be red, blue, green, yellow, and orange. So all arguments are 2 here and 5 here. It's supposed to be 10. The probability of winning is only 1. Head with red, head with tail, and so on. So it's 1/10. So it's less likely that the player will win. Let's think about this blank. It's blank likely that player will win a prize when using 5-section spinner than using 4-section spinner. It's less likely, because the probability of using 4-section spinner, it will be over 8, but here 1/8, but here it's 1/10. Actually 1/10 is smaller than 1/8, so the probability of using spinner 4-section spinner is better than the probability of using 5-section spinner. Okay. Also, we still doing what? How to do the probability of one event. If we flip the coin 3 times, first time, head or tail. Second, if it's head or tail. If it's tail, head or tail. And so on. First time, head, tail, head, tail, head, and so on. So you have 8 arguments. So the denominator 8. Okay. I need the probability of exactly getting 2 head. Exactly 2 head. How many 2 head? 1, 2, 3. So it's 3/8. So this is how to calculate the probability. Okay. Okay. So the tried one, let's solve the tried one. It's talking about, it's more likely that the coin flipped 3 times, as the last example, will land head up exactly once. Okay, we want to compare between, if I have the probability that 1 head exactly get 1 time. 1 head exactly, let's search for 1 head here, 1 head exactly, 1 head exactly, 1 head exactly. Okay, okay, so it's 3/8. 1 head exactly, probability of 1 head equals 3/8. Okay, we want to compare it with head up exactly twice. 2 head exactly, 2 head exactly, 2 head exactly, 1, 2, 3, 2 head exactly. Yes, 3 is 2. So probability of 2 head exactly equal also 3/8. So the probability is equal. They are equal. So it's no one more likely than the other. Both has the same chance. Okay? This is how to do the possible outcomes. All possible we learn now how to get all possible outcomes, which is the sample space, and the probability of an event. Okay? Okay. Let's take another example. This exercise, 1 of 3 contestants will be randomly selected to win a prize. 1 of 3 different Prizes will be randomly awarded to the contestants whose name is selected to win. The tree diagram shows all possible outcomes of this contest. I have 3 contestants, Pedro and Whitney and Brian. Each one of them has the probability to win. Prize 1 or prize 2 or prize 3. Prize 1 or prize 2 or prize 3. Okay? And so on. So all possible outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 possible outcomes, so the denominator will be 9. What is the probability that Whitney will win prize 2? It's 1. I have 1 over 9, so probability equal 1 over 9. That's it. This is how to calculate probability, okay? And all possible outcomes of an event or in compound events, okay? Thanks for listening. See you next time. Study well. Bye.